You're welcome to Science Tutorials with Pharmacology the Schoolboy. Today we are going to take a look at pharmacology, and we have a question here on the board. The question says, which statement best describes bioavailability? A. Relation between the physical and the chemical properties of a drug and its systemic absorption. B. Measurement of the rate and the amount of therapeutically active drug that reaches the systemic circulation. C. Movement of the drug into the tissues over time. D. Dissolution of drug in the gastrointestinal tract. E. Amount of drug destroyed by the liver before systemic absorption from the gastrointestinal tract occurs. The question source is Comprehensive Pharmacy Review, 8th edition by Leon Shager et al., page 78, study question 1. Now let us look at this question. The subject matter here is bioavailability. If you don't know the meaning of bioavailability, you'll not be able to answer this question. So what is bioavailability? Bioavailability actually is a measure. It measures the rates and extent or the amount of therapeutically active drug that gets to the what? Systemic circulation. You know, a drug has a medicine, a dosage form, has the active ingredient and the inactive ingredient or the excipient. Now, when this drug is taken orally, as the case may be, it's not that whole dosage form that will eventually exert effect. What will exert effect is the active ingredient. The active ingredient may be up to 500 mg, as in, for example, paracetamol, in the tablet, but not that 500 mg that will get to the what? Systemic circulation to exert the required pharmacologic effect. No. It's that amount, or in a more concrete terms, the percentage of the active ingredient that gets to the systemic circulation. That is what gives us the what? Bioavailability. So it measures not just the amount, also the rate is also important at which it gets to that systemic what? Circulation. So this is what bioavailability is all about in a nutshell. Now let us look at the options and select the option that actually describes what I just said now about bioavailability. Alright, let's go. Option A says relation between the physical and the chemical properties of a drug and its systemic absorption. This is not the answer. Actually, option A is talking about biopharmaceutics. Bioavailability is a part of biopharmaceutics. So this, if you look at option A, you notice that option A has an element of bioavailability, but it's not bioavailability. Biopharmaceutics talks about the physicochemical properties of a drug. It talks about its when it relates the physicochemical properties of a drug with its what? Bioavailability. The same time with its pharmacokinetics, its pharmacodynamics, as well as its toxicity. So biopharmaceutics relates the physicochemical properties of a drug with its what? Bioavailability, pharmacokinetics, pharmacodynamics, and the toxicity. So biopharmaceutics is broad. Bioavailability is just a part of it. So option A is not the answer. Now let's go. Option B says measurements of the rates and the amount of therapeutically active drug that reaches the what? Systemic circulation. Option B just described what I explained about bioavailability. I will tick option B as the answer, but let's go through before we can conclude. Now, option C says movements of the drug into the tissues over time. Movements of the drug into the tissues over time. Look at this quick. If you're not careful, you will think C, but it's not. This C is a part of pharmacokinetics. What is pharmacokinetics? Pharmacokinetics talks about the time course of movement of a drug in the body system. Or in a nutshell, it depicts what the body does to the what? The drug. Starting from the absorption, distribution, and elimination from the body. When we say elimination, we are talking about what? We are talking about what? Biotransformation or metabolism and excretion. So this is not the answer. This talks more of what? Pharmacokinetics. So I will not take this. Now let's go. Option D says dissolution of drug in the gastrointestinal tract. Dissolution of drug is not the same thing with bioavailability, but it relates to bioavailability because dissolution of drug, especially the drug that have limited solubility in water, most of them, dissolution process is a rate limiting step in their bioavailability. What it means is that their dissolution affect their what? Bioavailability. It's a very important step. If there is any issue in dissolution, sorry, the drug may not be bioavailable. So dissolution affects bioavailability, but it's not what? Bioavailability. It's not what? Bioavailability. Now, going a step further, you understand this dissolution of drug when you go into Noyes-Whitney's equation. We say that. Do I go there? Let me go there a bit. Okay. Now the equation says that the T is equal to this is the equation. This is the M. In fact, this equation has a lot to do with Fick's law of diffusion. In fact, this equation depicts the rates, the diffusion controlled dissolution, rate of dissolution of a drug. Now, let me bring in fixed equation here. Fixed equation says that dq dt is equal to this. After this, now we now compare the two of them. Before you can understand this, I want to say one or two things about fixed equation, fixed law. dq dt is the rates of diffusion of drug. You know, after disintegration, using oral administration for an example, after disintegration, what happens is what? Dissolution. The drug need to leave the dosage form into the systemic circulation. So it's moving from the dosage form via the intestinal villi, macrovilli into the what? Mesenteric circulation. From there it gets to the hepatic portal vein to the liver for first pass effect. Let's stop there. Now, for it to move from that dosage form, that movement passed through a semi-permeable what? Membrane. A membrane must be crossed. And there is this concentration gradient that must be passed for this to take place. Now, dq dt is the rate of this diffusion. While d is what? The diffusion coefficient of the solute. A is the surface area of the diffusion layer, the layer through which diffusion takes place. This is the surface area. And this is the partition coefficient, the oil to water partition coefficient. YH is the thickness of the diffusion layer. This is the concentration in both sides, C1 and C2, at the concentration in both sides, from area 1 to area 2. Now, these two equations, they have close resemblance, but if you're not careful, you may make the mistake of taking them to be the same. They are not exactly the same, even though they resemble each other. Now, this talks about mainly diffusion, but this is fixed law. This is Noyes-Whitney equation. This one is talk about diffusion controlled rate of dissolution of a drug. Now, remember, is the rate limiting step. Now, this is the rate we are talking about. This D is the same thing with the D here. This D is the diffusion coefficient of the what? Solute. That's the drug itself. But A here and A here are not the same thing. This one is the what? The surface area of the solid dosage form itself. This and this are the same thing. They talk about the thickness of the diffusion layer. This is the concentration. Of the solvate saturation, where this is the concentration of the bulk solution. The concentration of the what? The bulk solution. Now let's go to the next question. So I want to take this as the answer. Let's go to option E. Amount of drug destroyed by the liver before systemic absorption from the gastrointestinal tract occurs. I previously described the first pass effect. This talks about the first pass effect. You know, when the drug is absorbed, what happens is that it first enters the water through the mesenteric circulation. It enters the portal vein. From the portal vein, it gets to the liver, and in the liver exerts the first pass effect. Then the first pass effect is that the liver destroys almost most of the drugs, but not all the drugs that are susceptible to it anyway. But that first pass effect affects bioavailability. This only has affect bioavailability of such drugs. But it has nothing to do, it's not the same thing with what? Bioavailability. So from the liver now, it now enter the what? The systemic what? Circulation and the distribution into the what? Throughout the body. So this has effects on bioavailability, but it's not bioavailability. So this is not the answer. So by looking at all the options, the most appropriate option there is what? B. Measurement of the rate and amount of therapeutically active drug that reaches the systemic circulation. Thank you very much for your attention. Please, if you have any question, feel free to chat me up on WhatsApp. My WhatsApp line is on the screen. To watch our lectures online, please subscribe to our YouTube channel. We have 3 YouTube channels. The first one is Susan Academy. The second one is Susan Limited. And the third one is my personal YouTube channel, Pharmacology, the Schoolboy. My name is Pharmacology, the Schoolboy. See you next time.